Hey, have you ever just stopped and looked around? I mean, really looked? Everything is constantly changing. From the food you're going to eat later to the very ground beneath your feet, nothing stays the same for long. But how does it all happen? Today, we're going to dig into the two big ways our world transforms. We'll start with a small, familiar mystery, rust, and see how it connects to a much, much bigger story, how entire mountains get worn down over time.
I bet you've seen this 1,000 times, maybe on an old bike, a gate at the park, or a nail someone left outside. That flaky, reddish-brown stuff we all call rust. We see it all the time, but have you ever really wondered what is actually going on with that piece of iron?
And that's really the big question, isn't it? Is the iron just getting a sort of, a new coat of paint? Or is something much deeper happening? Is it turning into a completely different substance? The answer to that is the key to understanding a ton of stuff in our world. So, to figure this out, we're going to have to zoom out. I mean, way out. We're going from this tiny patch of rust all the way to the massive scale of geology. And believe it or not, the same basic rules that make a bike get rusty are also responsible for grinding down entire mountain ranges. It's pretty wild. Okay, our first big idea is a process called weathering. This is kind of step one in the grand story of how landscapes change. It's all about breaking things down. So what exactly is weathering? Well, to put it simply, it's just the process where rocks on the Earth's surface get broken down. But it's not a one-size-fits-all kind of deal. There are actually two major ways this can happen. Okay, so on one hand, you've got physical weathering. The easiest way to think about this is to imagine taking a cookie and just smashing it into crumbs. You end up with smaller pieces, but it's all still cookie, right? That's physical weathering for rocks. But on the other hand, you have chemical weathering. Now this is where the real magic happens. The minerals inside the rock actually react with things like air and water, and they form totally new substances. The rock itself is fundamentally changed. And this picture, it shows it perfectly. See those reddish layers in the soil? That's chemical weathering right there in action. The iron that was in the soil has reacted with oxygen over a super long time, and it's created something new. Does that sound familiar? Yep. It's basically the exact same thing that happens to our rusty bike, but on the scale of an entire landscape. But, breaking rocks down is only part one of the story. Once you have all those little pieces, they don't just hang around. Nope, they go on a journey. And that brings us to our next process, erosion. So, erosion is what happens next. It's the movement, the carrying away of all those little rock and soil bits from one spot to another. And here's the really important part to remember. Erosion is a physical change. Those little bits of rock are just getting a ride. They aren't turning into anything new on the way. Now, a lot of us hear erosion and immediately think of wind blowing dust around. But that's a bit of a misconception. The real superstar, the main engine of erosion, is actually water. We're talking powerful rivers, crashing ocean waves, even just simple rain. They are the primary forces that have carved out canyons and valleys over millions of years. Okay, so we've got rocks breaking down, and we've got them being carried away. We now have all the clues we need to officially crack the code on physical versus chemical changes, and finally, solve the mystery of that rusty bike. This table really lays out the rules of the game for us. With a physical change, nothing new is made, and you can usually reverse it, kind of like hitting undo. But a chemical change? That's a whole different story. It creates a brand new substance with new properties, and you pretty much can't go back. And notice that energy difference, too. Chemical changes often involve a big release of energy, like the heat and light you get from a fire. Let's make this super clear with a couple of examples. If you dissolve sugar in water, that's a physical change. The sugar molecules are still sugar molecules. They're just spread out in the water. You could get your sugar back if you just evaporated the water. But burning coal, that is a classic chemical change. The coal reacts with oxygen and turns into something totally different. Ash, smoke, gases. There's no way to unburn it. It's a one-way street. So let's apply all this to our rust problem. Here's exactly what's going on. First, an iron object gets exposed to air. Then it reacts with the oxygen in that air. And if there's water or moisture around, that acts like a catalyst, making the whole reaction happen way faster. The end result? A chemical reaction forms a totally new substance we call rust. It's flaky, it's reddish-brown, and it's definitely not iron anymore. All right, this is it, the moment of truth. We've looked at all the evidence. Let's go all the way back to that first question about the old rusty bike. Based on everything we've just talked about, what do you think? Is rusting a physical or a chemical change? It is absolutely 100% a chemical change. Mystery solved. The iron isn't just changing how it looks, it's actually reacting with the oxygen around it to become a brand new substance with totally different properties. You can't just wipe the rust off and have perfect iron underneath, because the iron itself has been transformed. Awesome. Now that you're basically a pro at this, let's try a quick pop quiz. What about cooking food? When you fry an egg or bake a cake, is that a physical or a chemical change? If you said chemical change, you nailed it. The heat from cooking sets off a chain of chemical reactions. These reactions create brand new molecules, and that's why cooked food smells and tastes so different from raw food. It's also why you can't, uncook an egg. Okay, so we've solved our big mystery and we aced the quiz. But why does any of this really matter in our day-to-day lives? Well, let's connect the dots. Understanding these two types of change is incredibly useful. The whole reason we paint iron gates is to create a shield, a barrier to stop that chemical reaction of rusting from ever starting. And those annoying cracks in the sidewalk? That's a physical change in action. Water gets inside, it freezes, it expands with some serious force, and pop, it breaks the concrete. When we get how these processes work, we can build smarter things, make our structures last longer, and protect our important monuments from the slow, steady march of time. So here's the big takeaway. The world is never, ever just sitting still. Change is always happening, from the blink of an eye flash of a match to the million-year-long process of a mountain wearing down. And now, you have the mental tools to see it and understand how it all works. So, my last question for you is this. As you go through the rest of your day, what changes are you going to spot? Will you see a physical change, like ice melting in your drink? Or a chemical change, like a piece of fruit slowly ripening on the counter? Keep your eyes open. You'll be amazed at all the science that's happening all around you all the time.